Assalamu alaikum. I am Dr. Mahmudul Hoque Jassy. I am from Dhaka Medical College. It is a leading medical college hospital in Bangladesh. Today we will discuss about parasympathetic nervous system, basic of the parasympathetic nervous system that is essential to understand the pharmacology and the effect of acetylcholine in the body, and what will happen if acetylcholine concentration is increased in the body. Like you will get increased acetylcholine concentration in the body in pesticide poisoning or organophosphate compound poisoning, or what will happen if you have decreased acetylcholine concentration in the body. You will get decreased acetylcholine concentration in the body in dhutura poisoning or belladonna alkaloid poisoning, and this dhutura or belladonna alkaloid contains atropine, and this atropine inhibits the effect of acetylcholine in the body. Let's start our lecture. So now this is your central nervous system, and this is a preganglionic neuron arises from the central nervous system, and this preganglionic neuron synapse with another neuron outside the central nervous system, and this is postganglionic neuron, and this postganglionic neuron innervate the target tissue. This is a target tissue, and on the surface of target tissue there is receptor. This receptor is called muscarinic receptor. So this is a muscarinic receptor, and the neurotransmitter that is released by postganglionic neuron is acetylcholine. Now we'll see what will happen if the patient is exposed to atropine or dhutura or belladonna alkaloids. Belladonna alkaloids means actually atropine, hyoscyamin, scopolamine, etc. So what will happen? So if you give atropine or you are exposed to dhutura to a person is exposed to dhutura, then this dhutura contains atropine and other substances, and this atropine blocks the muscarinic receptor on the target tissue. You can see this is a target tissue, and this is a muscarinic receptor, and atropine blocks the muscarinic receptor. So what will happen? Acetylcholine cannot bind with the muscarinic receptor, so acetylcholine cannot exert its action. So what is the effect of atropine? We can tell that atropine decreases the effect of acetylcholine in the body. So in the presence of atropine, endogenous acetylcholine cannot bind with muscarinic receptor, so acetylcholine action is decreased, so atropine equal to decreased acetylcholine effect. And second, what will happen if a person is exposed to pesticides or organophosphorus compounds? Look at, this is again the central nervous system, and this is the preganglionic neuron, and this is a postganglionic neuron, and this is postganglionic neuron release acetylcholine, and acetylcholine innervate the target tissue, and this is a receptor on the surface of target tissue. So there is an enzyme. Acetylcholine action is, when acetylcholine is released by this postganglionic neuron, acetylcholine action is rapidly terminated by the action of an enzyme called acetylcholine esterase. What this enzyme do? This enzyme cleaves the acetylcholine into choline and acetate. When acetylcholine is converting to choline and acetate, acetylcholine become non-functional, or it cannot activate the postsynaptic receptor. So acetylcholine esterase basically terminate the action of acetylcholine. What does OPC do? Organophosphorus compounds inhibits these acetylcholine esterase enzyme. This enzyme is inhibited by OPC. So when this enzyme is inhibited, acetylcholine cannot be metabolized. So in the synapse, acetylcholine concentration goes up. Because this enzyme is inhibited, acetylcholine is not metabolized. So acetylcholine concentration goes up. So you have in organophosphorus compound, you have increased effect of acetylcholine in the synapse. So in summary, we can tell that atropine equal to decrease acetylcholine effect in the body, and OPC equal to increase acetylcholine effect in the body. Now let us see what is the effect of acetylcholine in the body. So first we can proceed system by system. This is a gastrointestinal tract,
preganglionic neuron from central nervous system, and then postganglionic neuron releasing acetylcholine. And in GIT there is muscarinic receptor. Acetylcholine stimulates the muscarinic receptor. In the GIT, mainly on the surface of smooth muscle there is muscarinic receptor. So acetylcholine stimulate muscarinic or M3 receptor on the smooth muscle of GIT. When the M3 receptor on the smooth muscle of GIT is stimulated, there is peristalsis occurs. So acetylcholine actually leads to peristalsis. So when you are exposed to atropine or dhutura, what will happen? This atropine or dhutura blocks M3 receptor. This receptor is blocked, so acetylcholine cannot bind with M3 receptor. So there is decreased peristalsis because acetylcholine cannot exert its action on the GIT. When peristalsis is decreased, food bolus moves very slowly through the GIT, and when food bolus moves very slowly, there is increased water absorption from the food bolus in the colon, and when there is increased water absorption, your stool material become dry and your stool material become hard, and this leads to constipation. So atropine, effect of atropine or dhutura in the GIT is causing constipation. Second, if you give OPC or organophosphorus compound, OPC inhibits acetylcholinesterase, so acetylcholine cannot be degraded. So in the GIT, acetylcholine concentration goes up. When acetylcholine concentration goes up, there is increased GIT movement, and when there is increased GIT movement, this leads to diarrhea and vomiting. So this leads to diarrhea plus vomiting. Second, let's see the action of acetylcholine on the urinary bladder. This is the central nervous system, preganglionic neuron, postganglionic neuron. Postganglionic neuron release acetylcholine, and acetylcholine stimulate muscarinic receptor on the surface of detrusor muscle in the bladder. You know that on the bladder there is detrusor muscle, and on the surface of this detrusor muscle there is muscarinic receptor, and acetylcholine stimulate the muscarinic M3 receptor on the detrusor. When the M3 receptor on the detrusor is stimulated, the detrusor muscle actually contracts, and when the detrusor muscle contracts, urination occurs. So what will happen if you give atropine, or if a person is exposed to dhutura poisoning or belladonna alkaloids? Atropine or these atropine like substances blocks the M3 receptor. This M3 receptor is blocked by atropine or atropine like substances, so acetylcholine cannot bind with M3 receptor on the detrusor. So what will happen? When acetylcholine cannot bind with M3 receptor on the detrusor muscle cannot contract. So if detrusor muscle cannot contract, this leads to urinary retention. So the effect of atropine or dhutura in the urinary bladder is urinary retention. Now see what OPC do. Organophosphorus compound actually blocks acetylcholinesterase, you all know. So acetylcholine is not degraded in the synapse of the urinary bladder. So in the urinary bladder, acetylcholine concentration goes up, and this leads to excessive stimulation of detrusor. So your detrusor contracts vigorously. And this leads to involuntary urination or urinary incontinence. Let's see what is the effect of acetylcholine on the sweat gland. This is basically representative of sympathetic nervous system, though the neurotransmitter is acetylcholine. But again, in this nervous system there is preganglionic neuron come from the CNS, and this is a postganglionic neuron. Postganglionic neuron release acetylcholine, and acetylcholine stimulates muscarinic receptor on the sweat gland. When acetylcholine stimulates muscarinic receptor in the sweat gland, this leads to sweating. And what is the motive of sweating? The motive of sweating, because by sweating you lose heat from the body. You know, when we metabolize every food like glucose or fatty acid, and there is production of heat in your mitochondria, and this heat is lost by two mechanisms 2 to 3 mechanism is responsible for losing of heat from the body. Main mechanism, one of the mechanism is sweating. So acetylcholine causes this sweating and promotes loss of heat from the body. So does acetylcholine maintain your body temperature. So what will happen if you give atropine or dhutura or belladonna alkaloids? In the presence of atropine, acetylcholine cannot bind with M3 receptor. So there is inhibition of sweating. When sweating is inhibited, your body temperature cannot escape from your body, heat cannot escape from your body. So your body temperature goes up. This leads to atropine fever. And second, when sweating is inhibited, your skin become very dry. And when sweating is inhibited, body tries to decrease the loss. Body tries to enhance the loss of heat from the body. So what does the other mechanism of losing heat? The other mechanism of losing heat is to vasodilatation. When vessel is dilated, lot of blood coming to the capillaries and in your capillaries of your body, and when blood comes to your capillaries, heat is lost from the body. So for losing heat, there is vasodilatation occur in the body. But when there is vasodilatation, lot of blood coming into the capillaries, and when blood coming into the capillaries, your skin become red, because the red color of the red blood cell become visible. When these lot of blood coming to the capillaries, red color of the red blood cell become visible through your skin. So your skin become red. So in atropine poisoning or dhutura poisoning, we call that patient is red as a beet. So what will happen if you give OPC poisoning? In OPC inhibit acetylcholine esterase, so acetylcholine cannot be degraded or metabolized. So acetylcholine concentration in the sweat gland goes up. So in OPC poisoning, there is increase in sweating. Now coming to the effect of salivary gland, this is a CNS and this is preganglionic neuron and this is a postganglionic neuron. And postganglionic, this is a salivary gland, and on the surface of salivary gland there is muscarinic receptor, and acetylcholine stimulates this muscarinic receptor. And this salivary gland, you know that there is 3 salivary gland in the body. One is parotid gland, another one is submandibular, and another one is sublingual. So there is salivation occurs. So acetylcholine stimulates this M3 receptor on the salivary gland and salivation occurs. So what will happen if you give atropine? Atropine blocks the M3 receptor on the salivary gland, so salivation does not occur. So this leads to dry mouth. And second, what will happen if person are exposing to OPC? In OPC, acetylcholine cannot be metabolized because acetylcholine esterase is inhibited. So acetylcholine concentration in the salivary gland goes up, and this leads to salivation, and when excessive salivation occurs, this may present as frothing from the mouth. So what is the effect of acetylcholine on the other glands? This is a CNS, this is a preganglionic neuron, and this is a postganglionic neuron. Suppose this is a glands in the pharynx or bronchus or GIT or any other mucosa, and these glands contain M3 receptor, and this acetylcholine stimulates M3 receptor and promotes glandular secretion. So what will happen if you give atropine? If you give atropine, or if you are exposed to dhutura, this M3 receptor on the glands is blocked. So you have decreased glandular secretion from pharyngeal glands, laryngeal glands, bronchial glands, or other glands in the mucous membrane. So this leads to dryness of the mucous membrane. And if you are giving OPC to a person, acetylcholine cannot be metabolized, so acetylcholine goes up. So acetylcholine leads to excessive glandular secretion, and excessive glandular secretion from the pharyngeal glands, salivary gland, laryngeal glands leads to frothing from the mouth. Now coming to the lacrimal gland, this is a CNS, and this is preganglionic and this is postganglionic, and acetylcholine stimulates M3 receptor on the lacrimal gland. When acetylcholine stimulates M3 receptor on the lacrimal gland, there it causes lacrimation. So if you give atropine, this M3 receptor is blocked by atropine, so there is decreased secretion from the lacrimal gland, so this leads to dry eye. On the other hand, if you give OPC to a person, OPC inhibits acetylcholine esterase enzyme. So acetylcholine cannot be metabolized. So acetylcholine concentration in the lacrimal gland goes up, and this leads to lacrimation. So what is the effect of atropine? Atropine actually inhibits your sweating. This leads to dry skin. Atropine inhibits your salivation. This leads to dry mouth. Atropine inhibits your lacrimation. This leads to dry eye. And atropine inhibits your secretion of other glands of mucous membrane. Inhibits the secretion of glands of mucous membrane. So this leads to dry mucous membrane. So all these dry skin, dry mouth, dry eye, we collectively call it dry as a bone. This is the significance of dry as a bone, atropine or Datura poisoning. Now coming to the effects of acetylcholine on the pupil or iris muscles. This is CNS, this is oculomotor nerve, preganglionic neuron, and this is a postganglionic neuron, and acetylcholine is released. And iris has two kind of muscle. This black muscle is circular muscle. This circular muscle is also called sphincter pupillae muscle or constrictor pupillae, and there are some radial muscles. This radial muscle is called dilator pupillae, and this is the diameter of the pupil. This is the pupil actually. And when normally what acetylcholine do, acetylcholine stimulate M3 receptor on the constrictor pupillae muscle. So there is contraction of the constrictor pupillae muscle, and when constrictor pupillae muscle contract, pupil diameter goes down. This is the pupil diameter, and it goes down when this muscle contract. So what is happen? When you give atropine or person is exposed to Datura or belladonna alkaloids, M3 receptor on the constrictor pupillae muscle is blocked. So there is relaxation of this constrictor pupillae muscle or circular muscle of the eye, and this leads to increased diameter of the pupil, and we call it mydriasis. So atropine leads to mydriasis. Some spelling mistake. And in OPC, what does OPC do? OPC blocks acetylcholine esterase. So acetylcholine cannot be metabolized in the eye. So acetylcholine concentration goes up, and acetylcholine leads to contraction of the constrictor pupillae or circular muscle of the eye. When the circular muscle of the eye contracts, this leads to pupillary constriction, and pupillary constriction is called miosis, you know. Now coming to the effect on the heart. So this is a central nervous system, this is a preganglionic, and this is a postganglionic neuron, and postganglionic neuron release acetylcholine, and parasympathetic postganglionic neuron is actually innervate the SA node and AV node, and there is very little innervation of the atrial and ventricular muscle, very insignificant, but their main innervation is SA node and AV node. What acetylcholine do? This SA node contain M2 receptor, and this AV node contain M2 muscarinic receptor. Acetylcholine stimulate M2 receptor on the AV node, and when M2 receptor in the AV node is stimulated, there is slow down. AV nodal conduction through the AV node goes very slow, and when AV nodal conduction is slowed, you know that on the ECG there is increased in PR interval. And what does acetylcholine do on the SA node? When the acetylcholine stimulate M2 receptor on the SA node, and this leads to decreased depolarization rate of the SA node. That is, SA node is actually inhibited by acetylcholine. When SA node is inhibited, there is decrease in heart rate. So what does the atropine do? Atropine, in the presence of atropine, acetylcholine cannot bind to M2 receptor. So this leads to increase in heart rate and increased conduction velocity through the AV node. And in the presence of OPC, acetylcholine cannot be metabolized. So acetylcholine concentration in the heart goes up. And when acetylcholine concentration in the heart goes up, there is excessive stimulation of M2 receptor. So this leads to decrease in heart rate or bradycardia. So atropine, remember, in standard doses, atropine causes tachycardia by blocking M2 receptor, and in OPC causes bradycardia. But if in a person, if you give atropine in a very low dose, atropine actually produces bradycardia. because in low dose atropine stimulates the vagus nerve of the vagal center of the central nervous system, and this neuron is stimulated. In low dose of atropine, this neuron is stimulated, so there is release of acetylcholine and SA node is inhibited, so you have bradycardia. But if you give standard doses of atropine, this receptor is blocked, so acetylcholine cannot bind with M2 receptor on the SA node, and there is increase in heart rate or tachycardia. Second, coming to the effect of atropine acetylcholine on the respiratory tract. On the respiratory tract, this is a CNS, this is a preganglionic, and this is a postganglionic. Acetylcholine is released, and this is a trachea, and this is a bronchus. On the bronchus and bronchioles there is smooth muscle, and on the surface of smooth muscle there is M3 receptor. And this acetylcholine stimulates the M3 receptor, and when acetylcholine binds with M3 receptor on the bronchial smooth muscle, this bronchial smooth muscle constricts, so this leads to bronchoconstriction. When bronchial smooth muscle constricts, there is narrowing of the bronchus or bronchioles, so we can hear rhonchi. So what will happen if a person is exposed to OPC? Why OPC is very dangerous? Because if a person is exposed to OPC, acetylcholine esterase is inhibited, so acetylcholine cannot be metabolized. So in this synapse, acetylcholine cannot be metabolized here, so acetylcholine concentration here goes up. So there is excessive stimulation of this M3 receptor on the bronchial smooth muscle. This M3 receptor on the bronchial smooth muscle is stimulated excessively, so there is excessive bronchoconstriction, and that leads to respiratory distress, rhonchi, wheeze, etc. Acetylcholine also stimulates M3 receptor on the bronchial glands, and this leads to increased bronchial gland secretion. So in OPC, you have increased acetylcholine, so you have increased secretion from the bronchial glands, and increased excessive secretion from the bronchial glands leads to narrowing of the lumen of the bronchus, and you have respiratory distress. Now come into the ciliary muscles. We escape it. This is effect of acetylcholine in the ciliary muscle. This is cornea, this is suspensory ligament, this is ciliary muscle or ciliary body, and this is lens. When parallel rays of light come from a distance or infinity, they are converged in the eye by the lens and meet on the surface of retina. When parallel rays of light meet on the retina, we can see image clearly. But what happen if there is actually light comes from near object? Suppose if light comes from near object, suppose this is a near object, what happens if light comes from near object? If light comes from near object, this ciliary muscle contracts. When the ciliary muscle contracts, your suspensory ligament relax, and when your suspensory ligament relax, your lens become more spherical. So this is the picture. When light comes from near object, your ciliary muscle contracts, your suspensory ligament relax, and your lens become more spherical. So light can converge easily and it can meet into the retina, so you can see clearly the near object. So for contraction of this ciliary muscle, you need acetylcholine, because on the surface of ciliary muscle there is M3 receptor, and acetylcholine stimulates the M3 receptor, so your contraction of ciliary muscle, and when ciliary muscle contracts, this suspensory ligament relax. When the suspensory ligament relax, lens become more spherical, so you can converge the rays of light, so that rays of light can meet into the retina. This change in shape of lens by changing the stiffness of the suspensory ligament and changing the contractility of the ciliary muscle is called accommodation power of the eye. So by using accommodation power, you can clearly see the near object, but for this accommodation, ciliary muscle has to contract, And for contraction of ciliary muscle, you need M3 receptor and acetylcholine on the ciliary muscle. So if a person is exposed to atropine or dhutura, this M3 receptor on the ciliary muscle is blocked. So when the atropine or dhutura blocks M3 receptor on the ciliary muscles, there you lose the power of accommodation for near vision. So what will happen? Rays of light come, but lens cannot change its shape. So rays of light meet behind the retina, so you cannot see the image clearly. This is called blurring of vision. Your vision is actually blurred, and it is called, so when a person is exposed to atropine or belladonna alkaloids or dhutura, there is, we call it blind as a bat due to paralysis of the ciliary muscle or cycloplasia. So in atropine, you can see while not see many in atropine, there is, if you give standard dose, there is mild stimulation. What is the effect of atropine on the central nervous system? If you give standard dose of atropine, there is mild stimulation of CNS followed by longer lasting sedative effect. If you give more higher dose, there is acute confusion or delirium. If you give even more higher dose, if the patient is exposed to even more higher dose, there is hallucination. So, and if dose is much more, the patient goes into coma, and that is why patient behavior is bijari, and that is why when the person is exposed to atropine or dhutura, we call it mad as a hatter. And when OPC, person is exposed to OPC, acetylcholine concentration in the CNS goes up, and that leads to restlessness, confusion, convulsion, coma. So this is important feature of OPC in the CNS. Now coming to the skeletal muscles. So in a skeletal muscle, this is a spinal cord, and this is the anterior horn cell. From the anterior horn cell, there is motor neuron comes, and this motor neuron innervate the skeletal muscle. This is the neuromuscular junction, and this is the NM receptor is present on the surface of a skeletal muscle. When you are exposed to OPC or person is exposed to organophosphorus compound, these acetylcholine cannot be metabolized because acetylcholine esterase enzyme is inhibited. So in this synapse, in the neuromuscular junction, acetylcholine concentration goes sky high, very high. And this acetylcholine initially stimulates muscle contraction. So initial stimulation of the skeletal muscle leads to fasciculation and twitching of the skeletal muscle. But if acetylcholine concentration is high here, for a long time, the sodium channel on the muscle become desensitized. So this is called depolarization block, or muscle cannot be depolarized further. As the lecture time is short, I cannot explain it. I cannot explain it, but you remember initially there is a stimulation that leads to fasciculation and twitching, and after that there is muscle cannot depolarized, so muscle cannot contract. So there is the paralysis of the muscle, and this is the main cause of death in OPC poisoning, because if you paralyze the diaphragm, your respiratory system fail and you will die. So last but not the least, there is the mnemonics for you. Recognize mnemonics. You can remember the effect of OPC by these mnemonics called dumbbells. Here D stand for diarrhea because acetylcholine stimulates peristalsis, and in OPC there is excessive acetylcholine in the GIT, so you have diarrhea. E stands for urination due to excessive acetylcholine stimulating the detrusor muscle of the bladder. M for myosis because excessive acetylcholine stimulates the constrictor pupillary muscle in the iris. B stands for bradycardia because excessive acetylcholine in the heart inhibit SA node and AV node. B stands for bronchoconstriction because excessive acetylcholine causes contraction of the bronchial smooth muscle. E stands for emesis. It may be an effect of CNS effect or maybe effect of GIT. Both effect is involved for emesis. And E for excitation. Initially there is excitation of CNS and muscle, and then there is depression of CNS and muscle. L stands for lacrimation because excessive acetylcholine stimulate M3 receptor on the lacrimal gland. Excessive acetylcholine stimulate M3 receptor on the salivary gland. So there is salivation, excessive salivation, and excessive acetylcholine stimulate M receptor in the muscarinic receptor in the sweating gland. So there is sweating. So you can remember these mnemonics of OPC. And for atropine A blind as a bat because there is paralysis of the ciliary muscle, so there is loss of accommodation. Red as a beet because there is vasodilatation of the skin for losing heat because sweating is inhibited by atropine. So, and hot as a hair because sweating is inhibited by atropine, body temperature cannot be lost, so you become hot and body temperature goes up. And dry as a bone because all the skin sweating is inhibited, all the glands in the mucus secretion of all the glands in the mucous membrane is inhibited, so we call it dry as a bone. And due to CNS effect of atropine we call mad as a hatter. So thank you very much. We don't discuss the effect of atropine or OPC, what is the indication of atropine like substances, we don't discuss. We just form a foundation of parasympathetic nervous system so that you can read it in details. This is just a foundation. Those students who are read forensic medicine, they can find it useful. Just I just discussed the effect of atropine, OPC in the body and effect of acetylcholine. It is not any clinical indication I discuss. If possible, I will discuss in a later chapter. Thank you. Assalamu alaikum.